Hey everyone, probably get started soon. Hopefully you can hear me. We'll see once we get started in a minute. Maybe someone can let me know if they can hear me okay. Alright, thank you. We love that. Alright. Hey everyone, welcome to week 8, the data science lecture. Charles is unfortunately not here this week, so you'll be stuck with me. Hopefully it's an enjoyable lecture. It's the first time that I'm giving a lecture for this course, so I hope you'll be easy on me with this. But yeah, so something that I think you guys have been doing really well. You know, you've been working with arrays, objects, and things like that in P5, but we haven't really touched on data. So in this lecture, we'll be having a look at loading things, loading things from files, so CSV and JSON, as well as also pulling data from the internet. As we'll also have a look at interesting ways that we can use this data to enhance our artworks. And make them represent things from the outside world in a meaningful way. Some artists have been using data recently with COVID-19, as I'm sure that was probably something that popped into your head as well. Starting to taper off now as COVID-19 is kind of finishing, but still something that's pretty prominent in a lot of these data-based artworks. There's also, we have in Australia specifically, we had the really bad bushfire season in 2019, I think it was. And there's also a few artworks kind of talking about, things like climate change and the bushfires as well. So we'll have a look at a bit of that. But first things first, let's have a look at some admin for the course. So assignment 3 is due Tuesday next week at 9 p.m. Australian Daylight Time. So we are going into daylight savings here in Australia next week. So please make sure that you're aware of what that means for your due dates, especially if you're not actually physically in Canberra. If you need an extension for the assignment, do please ask. We're generally pretty lenient with that. So, if anything's come up or, you're having trouble or whatever, just feel free to get in contact with us using the submission app. Not the submission app, the extension app. Next week, the pre-lab entry is a storyboard for your major project. So I think we've released the theme, right? We've decided on one. Have we released one? You guys can let me know if we've released it or not. But yeah, there's more details on the lab page, so you guys can check that out. And then, in the week 9 lab, you'll also discuss your storyboard with your tutors and fellow classmates and things like that, and help develop a kind of, vision and plan for your major project. Generally speaking, this week's lab, the week 8 lab, will be like an image and data lab. And then after that, you won't really have any more like coding labs so much. They'll be more focused towards working on your major project. So that's pretty much how the rest of the course will be looking from here on out. But yeah, without any further ado, let's get into the data science section of the lecture. So yeah, working with data. As mentioned before, you already know kind of like how to use arrays and objects and things like that, but we haven't really worked with data so much so in P5. And when we think about working with data, you could think about it like this on the slide, for example. So, working on a very low level, working with zeros and ones, moving through a pipeline, for example. But that's like a very low level way of looking at data or interpreting data. So how else might we look at data in this course, especially, or how else might we use data for for artwork? So one of the ways is structured data. So things like spreadsheets, I'm sure that you've thought of. But yeah, so as I mentioned, you guys have already sort of been working with data, but just not quite what we're going to be covering in this lecture. So, variables, arrays, objects, and P5 are all, examples you could consider data. But we haven't actually loaded anything externally into the sketch as far as data goes, apart from potentially, images and audio files. So yeah, some examples of data, as I mentioned before, spreadsheet, very common, probably pops into most people's heads when they think of what data looks like. But we can also have other forms. So here we have some structured text, the complete work of William Shakespeare, probably pretty long, I'd imagine, probably a pretty large file. We can also have musical data. So here we have some MIDI data being displayed, in a time fashion. And yeah, data can encompass a lot of things. So if I encourage you after this lecture to go and have a look and see what you can find and have a play around with it, because it is really quite fun and interesting. So data art usually has 3 steps, or at least when we're working with P5. So the first step is going to be getting the data into P5. This is going to be using some of the P5 built-in functions that we're going to have a look at. Then once you've got the data loaded in and assigned to a variable, you want to access the data. So whether that be an object or an array, however it is, you're going to be able to access that data and actually use it to modify things in the sketch. The theme for the major project is still TBA on the assignment page. All right, well, the theme for the major project is after hours. That is the general theme. So I hope I'm not stepping on Charles' feet by announcing that. But yeah, you heard it here first. That's going to be the theme for the major project. Anyway, yeah, so that's step 2. And then step 3 is drawing, moving, sounding stuff off, whatever it may be, using using information about that data to affect something or, draw something in your sketch. And I would say, generally speaking, you guys have been doing pretty good at steps 2 and 3. So can you see my mouse? It sort of moves around. Yeah. So yeah, step 2 and 3. You guys have already been doing in the forms of variables, arrays, booleans, things like that. You've already been accessing elements within your data, and then you've always, you've been drawing things based off those variables and having them change over time. So yeah, you guys are already pretty good at 2 and 3. So really, we're only going to be looking at number 1 here in this lecture. So looking at the first thing here, tables. Spreadsheets, things like that. So that's a pretty common way of representing data. In P5, and what you're most what you are most familiar with is probably Excel files. They have an XLS or some form or shape similar to that extension, or potentially numbers if you're a Mac user. But yeah, we don't really do that here in the computer science realm, mainly because it's kind of harder to pass data out of those files. Instead, what we would like to use is something called a CSV, or a comma-separated value file. And as the name suggests, it's basically just a table, but instead of, visually representing it in a spreadsheet or something like that, you have a way of delimiting the lines such that it is passable by a machine easily into something that would look like a table. You can easily make CSV files, although it can be pretty easy to mess with the formatting, especially if you are putting strings in there that also happen to have a comma inside the string. You need to make sure that you're quoting it out correctly and things like that. So most common spreadsheet applications have an export function that you can use to export your files to CSV, and then use that to load it into, and then load those CSV files into P5. So we won't look at that today. We'll be looking at some like pre-generated CSV and JSON files. But yeah, just know that if you find an Excel file or something like that that you want to use data from in P5, then it's very easy to convert that. So what does a table look like? Well, here's one that Charles has prepared earlier. We have some, animals here and some numbers. There's no header here though. So header being the first row in a table that kind of tells you what the columns are, what they mean. But this one unfortunately does not have a header. So I mean, echidna 1400. Who knows? It could be anything. Four, maybe this column might be legs. Maybe that makes sense. So we'll have a look. And here's how we would represent the previous table in a CSV format. So the animal strings are, quoted out and represented as strings, and then followed by a comma to separate them, and then followed by the next four columns after that. And they all pretty much match up the same here. So you can imagine that, the second column, which is going to be the first number, is going to be 12, 1, 3, 263, and 5. So it all flows in pretty nicely. It's not necessarily the best thing to look at when it's unformatted, but as far as your computer goes, it's something that it can read pretty easily. And yeah, as I mentioned before, header row, basically something that's going to help us interpret what these columns mean. A header row is, as I said before, just a way to name the columns inside the CSV. So here we can see that the first column is, as we kind of correctly assumed, was animal. Second one is count. So we can probably assume that this is Charles. How many of these animals Charles has seen from his house, I guess. So Charles has seen 12 kangaroos, an echidna, 3 sugar gliders, 263 noisy miners, and 5 magpies. I don't think that's how you actually spell miner. But yeah, noisy miner is a very common bird in the ACT. Very, very interesting that he managed to see 3 sugar gliders. They're very cute animals. I'd highly recommend Googling them if you don't know what they are. Very, very cute. But yeah, so that's pretty much what a header row is. So let's dive into loading them into P5. So P5 has a load table function, and yeah, if you want to use it, it looks a bit something like this. So what do we have here? Let's unpack it. We have data, which is going to be our variable, presumably is equal to load table, which is our function call, and then assets/animals.csv, which presumably is going to be our CSV file. And it's going to be located in the assets folder, as we usually do for things that aren't JS files and whatnot. We usually put them in the assets folder. We also have another argument here, CSV, and another argument header. So this returns a table object, not an array. So let's have a look at the load table function on the reference. Hopefully that works. All right, cool, it does. Hopefully, yeah, I think so. So let's see. Is there anything new here? Preload. I think we might have gone over preload before inside one of the labs or one of the lectures, but if not, that might be a bit new to you guys. Basically, the way that preload works is that it effectively runs before setup and before draw. And if there's anything that takes time, so for example, loading a file, it takes time, or, making a web request, it takes time. If there's anything that takes time and may not necessarily finish once that line itself has actually run, you might have encountered this with the Poker Garden or similar labs, then this function will wait for those to actually complete before moving on to setup. So it's good for things like loading pictures, loading audio, loading data. We want to use preload so that we are not moving on further in the sketch before things are ready. So that's what preload is, if you weren't aware. But yeah, so let's have a look what's down here. Load table, file name, yeah, we configure that. Extension, yeah, okay. So if it's a CSV or not, presumably. Yep, CSV or SSV or tab separated values. So yeah, CSV is the general kind of like file name extension that we have for these files, but they're not always necessarily separated by CSV. For example, if your data has like a lot of commas in it for whatever reason, you may want to separate it by tabs or spaces or something else. Header, string header, to indicate if the table has a header row. So when we were having a look at the animals CSV, we saw that it had a header row, so we want to be using header in our argument here. What else do we have here? Callback. The function executed after load table completes. On success, the table object is passed in as the first argument. Error callback. Function to be executed if there is an error. Response is passed in the first argument. Yeah, so you may not have seen much in the way of callbacks yet. As I mentioned earlier, the we use preload because we want things to be finished before we start say setup and things like that. If you don't do that, you can use this notion of what's called a callback, so that a callback is called once the function finishes, or once the data would be loaded in this instance. So for example, if you needed to do something as soon as the data was loaded and do it once, then you could use this callback. You could use this callback argument to pass a function into the function, which is kind of cool. But we're not going to do that here, at least. We may have a look at it later on in the lecture. But yeah, that's pretty much how it is. And let's see, how are they accessing the data here? So we have table, it's a load table, and then get row count, it's the total amount of rows in the table, column count, total amount of columns, get column name, yep. So that gives us an array with the column values, makes sense. It's a loop iterating over the table, yeah. So pretty common stuff. We'll have a look at it in a bit more depth later anyway, so don't stress too much if that kind of went a bit over your head. All right, so let's have a look. Using P5. So yeah, P5 table objects have functions to access data by name or by index. So yeah, as you saw a little bit in that in the reference file. So we have once we've loaded our data into our variable, so you can think of back before we have data is equal to the get table function. So data get row 2 is going to get the third row. Remember, 0 indexing. And that will be just an array of the values in the second row. So if we come back to our CSV, what do you think that this line would actually return? Data.getRow2. Any ideas? I'm not sure if Charles usually has interaction or waits for answers. Maybe this might be a mistake. I'll take a coffee break while we wait. Yeah, the echidna row. Yep, that sounds right. I think so. We'll have a look later, but I'm pretty sure that that's what the case would be. Oh, actually, would it be the echidna row? Thinking about it, right? If we're telling it that it has a header row, is the header row considered row 0, or is kangaroo considered row 0? If kangaroo is considered row 0, then echidna is probably not considered row 2. So we'll have a look at that. A bit of a trick. Almost stumbled me as well. All right. So yeah, similarly, we can also get columns. Yeah, probably the next one. We can also get columns. So if we have a look back at our data again, we can see here that animal was the name of the first column, or the 0th column, if we want to be computer scientists about it. And then we can use that as an argument to the get column thing, and we'll get an array of the values in that row. In that column. Similarly, if we want to get a specific cell, so if you were like selecting a cell in a spreadsheet, for example, then we can get the row and then get the column, and then that will obviously give us the intersect will give us a single value. We can also do 2D array kind of accessing, or like a matrix. So using direct, we can convert it to an array and then use like direct indexing, like we are using here, to get particular elements. Either way is fine. We're going to have a look at the table methods for now, but yeah. So let's have before we go into this one, let's have a look at doing a toy example with the animals. So hopefully this is working. Hopefully you can see this editor. Maybe I might need to increase the size for you guys. Everyone, let me know if the text is a little bit small. I can probably, yeah, after, yep. Hopefully that doesn't ruin the way the page is. Hopefully the text is readable for you guys here. So here is a little play area that I have organized earlier. You can see that I have the assets folder here in the sketch files, as well as the animals.csv that we saw before already loaded in. So you can do that to add files onto the online editor. You can use these little drop downs here to create a folder, create file, upload file, and then similarly, if you want to upload things into folders, you can also do the same thing here. So create file, upload file, etc. So I've just copied and pasted the data about the animals here, our animals CSV, and we're going to use the P5 functions to basically draw a little artwork based on this information. All right, so let's have a look here. So first things first, we want to create our global variable for the data. Make sure that we can access it outside of the functions that we define it in. I'm sure you guys are all very familiar with that at this point anyway. Then we want our preload function that we saw from the reference, and we want to load our data. So data is equal to load table, which was the function that we just looked at. And so where is our file? Our file relative to the sketch file is in assets, animals.csv. Then we also needed to give the load table a type. So it is a CSV, as we saw before. And it also has a header row as well. So this is going to load our table into the data variable, and then we're going to be able to access it in the setup function. So let's just have a look and make sure that things are going okay. So what happens if we print data just as it is? All right, nice. So it's an object, and we have some columns: animal count, legs, arms, wings. Yeah, makes sense. And we also have some rows, each row being an object itself. Let's have a look at the values. Yeah, kangaroo 122220. Sure. So pretty standard stuff at this point. Let's try and get let's have a look at row 2, because we were talking about that before. Which row is this actually going to be? It's the sugar glider. So yeah, so the row after the echidna row. So basically, as we were talking about before, the 0th row is not the header row. It's going to be the first row in the data. And then we can also get a specific thing about the sugar glider. So let's see how many sugar gliders Charles has seen. So what was the header for that one? I've forgotten. It's escaped me now. Count. So if we get count, then we can see that Charles has seen 3 sugar gliders. I don't know what time period that was in or how long, but now we know that information, and we're much better for that. So let's see what else we can do here. So generally speaking, we're probably not going to be doing too much of this, get row, get count, things like that. We're probably going to iterate across our data to draw something. So let's have a look at what kind of artwork we can draw here. I'm not going to do it inside the draw function, because we're not going to do something that's moving. We can kind of just write it in setup and get away with it. So the fact that it's going to happen once, basically. So first things first, let's draw a background. Change the color mode, because I like to work in hue, saturation, brightness instead of the standard RGB color mode. And let's turn off stroke, because I'm going to be drawing some ellipses, I think, based on these animal sightings that Charles has had. So here's the first kind of trick, I suppose. We want to iterate over the data that is in that is in data, ironically. So one way of doing that is that we can use this kind of notation. So we say const. I don't know if you guys have touched on const or not. Const is basically just another way of saying let, but instead of let where you're creating a variable, const, as the name kind of suggests, is creating a constant, something that is going to remain the same or not going to be updated, things like that. I'm sure there's like a more nuance to it than that, but you guys can have a look at that later in your own time. So we're going to say const row of data.get rows. So basically what this is doing is that it's going to iterate over every row in the data variable and assign it to the constant row for use within this for loop. So for example, we can say print row.get animal, which was the first column inside our CSV, and we can see that we have a kangaroo, an echidna, a sugar glider, noisy miner, and a magpie. So yeah, pretty simple stuff. We can also, do whatever with this information. Because I have looked at this a little bit ahead of time, there is actually a bit of a trick here. So I'm going to print something out now, and you guys are going to tell me what you think of this. So just put this line in here. So we're getting arms of this specific row, and we also want to know what type arms is. Now, if we have a look back over at our animal CSV, we would expect arms, which is the second to last value, is going to be a number, right? So let's have a look. We expect it to be a number, and what is it actually? It's actually a string, which is not really what we want. And this can be kind of one of the dangers of working in JavaScript. You have these things that basically JavaScript tries to do its best to interpret what you want and do it without throwing an error or breaking. And sometimes with throwing an error, but not breaking. But yeah, here we've loaded this data into the table, and it's interpreted these numbers that we've given it as strings. So if we were to perform, arithmetic or something on that. So for example, arms here is in this row is a 2 for a kangaroo. If I were to add a 1 to it, what do you think the result's going to be? I won't wait around too much to find out. We're going to have a look anyway. Yeah, it's going to be concatenated here. So 21, which is not really what we wanted. If kangaroo has 2 arms and we add 1 to it, we kind of would expect 3 to be the result, not 21. So unfortunately, that's just the way that the load table thing seems to work. Maybe someone knows how to fix that or how to do it better than I have, and they can let us know in the chat or later on. But basically, one of the ways that we can kind of fix this is by converting the value. So, for example, if I was to say let arms equal row dot, oh gosh, if I could spell it correctly, row get arms, then what I could do, this is still going to be a string here, but P5 has some functions in that we can use to convert things. So I can just throw this in a function called int, and then that will convert the arms from the string 2 for a kangaroo to the number, or the integer 2, so that we can do some maths on it. And that's kind of what we want to do. So I'm gonna draw some ellipses based on these based on this information, and we'll see what it looks like. So let's I'm gonna draw an ellipse that is kind of tall for wings. So if something has wings, it's going to be a taller ellipse, and if something has arms, it's going to be a wider ellipse. And let's see what that looks like. Of course, not every animal has both arms and wings. So some animals also have neither. So we still want those circles to be, there. It's just that, so we're going to have to maybe add a little bit of an offset to them so that they still show up even if they don't have arms or wings. So we're going to do the same thing for the wings. And then we're going to draw an ellipse based on them. So our ellipse is going to appear somewhere. So random width, random height. So it's going to appear somewhere on the sketch. And then we are going to say we're going to give it the width based on the arms, and we're going to multiply that by, say, 50. I think 50 pixels sounds about right. And then we're going to do the same thing with the wings. So wings times 50. But as I mentioned before, arms and wings aren't necessarily always going to be above 0, and we still want to see these circles. So what we're going to do is also just add an offset so that every animal can at least be seen, even if they aren't necessarily a strange shape here. So let's have a look how this is kind of looking. Well, actually, maybe we'll set up a fill first. So fill random 360. If you don't know much about the HSB color mode, go have a look at it. I think it's quite nice. It makes it easier to kind of get random colors in like the same kind of color palette. So for example, here I'll do like a more of a pastel color palette for our animals. So we have a low saturation but a somewhat high brightness here. And that should give us hopefully a nice little color palette for our sketch. So let's have a look at the output. Yeah, so not too bad. We can see our circles here. So this one's circular, which means that it has the same amount of arms and wings, but we can probably think of that as also not having arms or wings. So if we were trying to locate which animal this circle was, you guys can see my cursor, right? Someone can let me know if they can see my cursor. If we're trying to identify which animal this was, we can come back over here and have a look, and we can see that we're looking for something that has no arms and no wings. And having a look through this very small data set, obviously you wouldn't do this if it was like 50,000 rows long, which we'll have a look at a little bit later. But yeah, if we're having a look at this little toy data set, we can see that the echidna does not have arms or wings, which kind of makes sense, right? Because an echidna is a quadruped. I think it's the word for that. Echidnas are also very cute animals. Australia has a lot of interesting wildlife, so if you don't know what an echidna is, I suggest Googling it as well. But yeah, so we can assume that this little dot here is the echidna, and if we keep running the artwork, we'll see that it changes each time because we haven't set any specifics here. And even each time we refresh, we still get a somewhat cohesive color palette, even if whereas if we were to say compare that to fill random 255, the standard, the standard one, and we also change the color mode back to RGB, then you can see that things get a little bit more, it's still nice, but things are a little bit more different, a little bit less consistent, not always working together. We have some very pale colors over here, and then we have some very highly saturated, very vibrant colors over here. So depends what you're going for. I personally like HSB as a means for getting us a bit more of a consistent color palette, because you basically have the first argument here being 0 to 360, depending, indicating where on the color wheel you're going to go. And because it's a wheel, it's circular, so 0 and 361 are the same thing basically. Yeah. So that's a quick little look at a database artwork here. Doesn't really make sense, having circles of different widths and shapes depending on animals, but it's just a toy here. So let's have a look a bit more at what else is going on. So as I mentioned, the animals CSV is it's rather small. It's a bit of a toy data set. So generally speaking, the data sets that you're going to find online are going to be a lot bigger and hopefully also covered by licenses. So here's one that Charles has found, the World Cities CSV. Sorry, excuse me. I'm just going to take another. So this is something that's been released. This seems to be a company has released this information, which is basically just, data about cities around the world. And we can download the basic version for free, it seems. Yeah. And, it probably has a bunch of interesting things in it. Cute cup. Yeah, thanks, Julian. So yeah, it should have a whole bunch of interesting data points that we can use, and also, give us a little bit of something more interesting to work with than our, 5 circles based on animals, arms, and wings. So we can have a look at this data set. So we'll just come over here and hit the download button. I don't know how much of this you're going to be able to actually see because I am sharing my browser specifically. But yeah, we agree to the terms of service. We don't read those things. We don't read those things here. So we have a look. So we've gotten a zip. Hopefully you guys can see that. So I'm going to go ahead and unzip our zip. Extract here. Stop. So, yep. So we've gotten our World Cities CSV as well as an Excel from that zip. Sorry, you can't see it. You're just going to have to imagine that you're seeing what I'm seeing. But yeah, So they have kindly already exported the Excel as a CSV, so we don't have to open that up in like, Sheets or whatever it is to convert that over to CSV. So let's have another look back on the online editor and see what we can do with this. So let's see, did I have one prepared nicely for this or not? No, I didn't. All right, let's just stay back where we were. And do a new one. So we are going to upload our file. So just come over here, upload file. It's going to ask us to drag and drop our whatever we want to upload onto here. So I'm going to drop the World Cities CSV on here, and it's a couple megabytes, so should be done pretty quickly. And then yeah, here it is. You can see it here in our assets folder, and we can have a look at it. Or we could if it wanted to render. So the World Cities CSV is 4 megabytes or nearly 5 megabytes. And I guess P5 doesn't want to render that. So we're going to just let it, we're going to assume that there's data there, and maybe we'll open it and have a look at it in P5. So I'm just going to go ahead and get rid of the existing code that we had here and have a look. So we're no longer loading animals. What was it? It's world. Just gonna quickly grab the name here so I don't have to type it back out. There we go, World Cities CSV, and I'm going to assume that they were nice enough to include a header so we actually know what the data is. So likewise, like before, we can kind of use our print debugging to have a look at the data that is available to us. So let's have a look at what columns are available to us inside this data set. So taking a little bit longer here. Remember that preload needs to finish before our sketch is going to run, so it needed to load it up and pass that 4 megabyte file. So here are the columns that are included in our data set. So we have city ASCII, lat, long, presumably where the city is, the country that city exists in, some other things that I don't know. Admin name, don't know what that is. Capital, I guess if it's the capital of the country, maybe, I'm not sure, or potentially the capital inside that city. I don't know. My geography is pretty awful, so we're just gonna gloss over that. The population and some kind of ID. I don't know what that ID is going to be either, but I mean, we could have a look if we wanted to, but potentially not useful information for us for drawing an artwork. So this is kind of the things that we're getting here. So let's use this again. We can do another little bit of artwork for this kind of larger data set and see how that ends up looking. So let's see. We can do I'm gonna borrow the same kind of color palette that I had before. So random 360, 30, 80, I think it was. To get that nice kind of like pastel color set. And I think what I'm gonna do is I'm gonna do something really simple. I'm just gonna draw ellipses for each city based on its population and see what that looks like. So we're going to want to say let population equal row dot get population. I'm going to assume that they have been nice and made the populations be integers, because we don't have anyone who's less than a whole person here. We count people by whole numbers. So I'm going to safely assume that we're wrapping this in an integer to get it from that string to be a number that we can actually work with. Cities are kind of large, so if I were to just use population directly as the radius for our circle, we'd probably not see anything but one circle. Just kind of would make our sketch just be one whole color. So we're not going to do that. We're gonna size our circle a little bit based on this population, as well as let's just see what which city has the highest population overall as well. So max population is equal to -1, and then just say if population is greater than max population, then we are going to update max population to be population. And then after this loop iteration is done, we're going to say print, here's a little hack for you if you didn't know. So you can use backticks here to get a format string in JavaScript. So we're going to say population, I'm sorry, highest population is max population. And then that is going to, if I did it correctly, that would print us a nice little string using this variable in our format. So we have the $sign here, and then the squiggle brackets to basically take our variable and make it part of the string. So if we just run this now, where we're not doing anything, we're not going to see anything on the screen, but we're going to find out what the highest population is. So yeah, what's that? 333 million? Yeah. Nearly 4 million. So highest population city, nearly 4 million. I have no idea when the census data was gathered or whatever city that was. We could find out what city that was if we wanted to, but I'm not going to bother. But yeah, something that's nearly 4 million pixels wide is probably not going to fit on my monitor as wide as it is. So instead, I am going to, is that 39 million? Maybe I did indeed misread the amount of commas. Thank you, Melody, for correcting me on that. I thought 3.9 million sounded a little bit low. So yeah, maybe that might be like, I don't know, Tokyo Metropolitan or something like that. Who knows? But yeah, so now that we've pulled out this bit of data, we know that it's going to be something rather large. So what we're going to do is when we draw our ellipses, we're going to divide the population so that we have something that's a little bit more, visible on our rather small canvas comparatively. So again, we're going to do the same thing. So random width, random height. Gosh. Can't type today. And then we're going to use the population as the size for our ellipse. However, we're going to divide it. Let's see. Let's just divide it by 100,000. I would imagine that most cities that are on this bit of data might have at least 100,000 people so that they can at least be 1 pixel. But we can't have the big cities just being completely blown out of proportion. So I think maybe 100,000 might be something nice to divide it by. But that's, let's just see what that looks like. And maybe we might need to tweak it later on. Oh, it would be good if I could spell. Yes. Critical mistake. I have tried to use population before I've assigned it. So yeah, that's basically just saying I was trying to use population here, but I defined it down here. So I was like, what does that mean? I don't know what it means. But now hopefully it does actually understand what population is. So yeah, somewhat cool. I've got a little splat here. So you can see that we have a bunch of small cities here and there. And then we also have some mega cities as well. So yeah, not too bad. Maybe we can make it a bit brighter. See if that makes it pop a little bit more. Yeah. Kind of cool. But yeah, you can probably imagine some of these mega cities. So as I mentioned before, Tokyo Metropolitan, and then we have maybe some of the smaller cities. So I don't know, Canberra. I think Canberra has a little bit over 100,000 people. So Canberra might be one of these single pixel things. And then yeah, it kind of gives you a bit of perspective based on population sizes for cities here. If there's something that's just this little speck, and then we have these mega ones like this one here, for example. What's the smallest on the data set? So we can do the same thing. So let's have a look at the min population. Let min population. And as a default value, we're just going to make it something rather large so that when we do comparison, it's easy to find what's actually smaller. And then so we'll come back down here. If population is less than the min population is equal to population, and then we can edit our little format string to also print out the smallest population. Now remember, this is not a comprehensive data set because we have not paid the company money to to get their more comprehensive data set. So this may not be representative. This will give us an idea of the smallest that they've bothered to include in the free tier, but it's probably not going to be the smallest that they've recorded. So let's have a look. Smallest population is population Oh wait, no, it's not population. It is min population. Sorry. Let's have a look. Oh, I didn't do it right. That needs to be a dollar sign, not a percentage sign. All right, let's have a look, shall we? Smallest population, 0. Well, let's put in an extra bit of pre-processing, so we don't hit that. We get a town that actually has a person in it at least, and population is greater than 0. Now let's have a look. 2. So there's a town of 2 people. Yeah, I wonder what town that is. So we can also do something similar. So let's say let min town name equal and then we'll just update that variable inside this for loop. Min town name is equal to row dot get city was the name of the column. So row dot get city, and then let's see which city has 2 people in it. Smallest population. Min town name. All right, let's have a look. Which city has 2 people in it? Okay, yeah, look, I'm not going to be able to pronounce that, but I will Google it and see where it is. Let's have a look. Molmine is the 4th largest city in Myanmar. Wait, that doesn't sound right. It's probably not that one. Let's see which country it's in, I suppose. I'm going to spend too much longer on this, but I am now sort of curious. What was it? Row, get city, but it's not going to be city. It's going to instead be country this time. Alternatively, I could grab the latitude and longitude and try and navigate there using Google Maps, but hopefully this will give me enough information. Oops, I need to also print this as well. Otherwise, the data is useless to me. Myanmar. I wonder. So it is the city. 4th largest city, 2 people. Alright, I reckon that their data is probably just wrong. Hopefully the rest is not wrong. It's a little bit strange that this one is coming up as a population of 2. And then yet it's the 4th largest city in Myanmar. That is what it said, right? Yeah, Myanmar. Not sure what's going on there. We'll just assume that something's wrong with the data. The company that, is in charge of it has done something wrong and not me, because, I definitely didn't do anything wrong. But yeah, here's our little, artwork based on populace. There is extra data here, so we could work with more things. So for example, I could make it we have latitude and longitude, so we can probably plot them on this little bit, on this little window here to make them look like the world. So let's have a look at how we might do that. So we're also going to have lat equals something and long equals something. So latitude and longitude, if you know how that number system works, then that's great. But basically they're going to be some kind of coordinate system for where things are in the world, and they're not going to be ints this time. They are going to be floats or doubles potentially. So I'm going to use the JavaScript number function to convert those. So similarly, row get what is this, lat, and then we're also going to do the same thing here to get the longitude, but I think long is LNG. Yeah, LNG. So longitude. And then we are going to do a little bit of post-processing on that, because these are going to be, I think longitude's like negative 180 to 180, and then latitude is going to be, I think, negative 90 to 90. I think that's how it works. You can correct me if I'm wrong, as I mentioned. My geography and various other, location-based information skills are not the greatest. So what can we do? We can convert these so that they're a little bit easier to work with. So what I am going to do is I am going to take the latitude and I am going to add 90 to it so that it is now between 0 and 180 instead of negative 90 and 90. And then I'm also going to divide it by 180 to get it to be between 0 and 1. I'm going to do something sort of similar for longitude. So I'm going to divide it, going to add 180 to it to get it to be between 0 and 360. And then I'm also going to divide it by 360 to get it to be between 0 and 1. Then what we can do is that instead of doing random width and random height, we can then use the latitude and longitude to plot it. So our x is going to be longitude, so long times width, and then our y is going to be lat times height. And let's have a look how that looks. Not too bad. I think the world might be upside down. This kind of looks like what? South America, I think it is. Yeah, or yeah, I think. I don't know. It's kind of hard because it's upside down. Let's invert that then. Presumably it's going to be the latitude is wrong. Let's invert it. Yeah, there we go. So we can see here that yeah, wow. Okay, some very big cities around the place. Let's maybe divide this by a slightly larger number so we can get the circles down a little bit. All right, nice. But yeah, so we can kind of make out the world here. So we've got America, South America, Africa, Europe, Asia, and then Oceania is around here. So Oceania, we got some somewhat sized cities. There's New Zealand down here where I'm from. Woo, love New Zealand. That's probably what Auckland, Wellington, Christchurch. I'd imagine the rest of New Zealand doesn't register because they're tiny. Classic. But yeah, we can see that they're where kind of the weight of the world is. I suppose there's a lot of people in Asia area. So yeah, quite a decent amount of people in Europe as well. Same for America, South America. Yeah, we can kind of see where the population sits, which is kind of interesting. But yeah, so that is going to be our little artwork here based on the population data. So yeah, not too bad, not too bad. But yeah, let's move on. So we've been working on CSV things, basically loading them into a table and then using those data. But there is another. Sorry, I'm gonna take a sip. I feel like my throat's getting a little bit dry. Yeah, it's a cute cat cup, Julian. See, it's got where's my webcam there? It's got like a little cat and little paw prints on my coffee cup. Anyway, so another way of representing and storing data is JavaScript object notation, or JSON. So it's a little bit similar, a little bit different to JavaScript files or JavaScript objects and things like that. Basically, JSON is a relatively common way of sharing data between websites, things like that on the internet. It's for all the computer science peoples, we'll also touch on it a little bit later. So APIs generally use JSON as the text format for transmitting and passing data. But yeah, so what else can we say about JSON? Well, let's just have a look at it, shall we? Let's have a look at a JSON file. So what does a JSON file look like? And hopefully this will be immediately familiar for what an object looks like in JavaScript. And, you'd be exactly right, because the JS in JSON stands for JavaScript. Wow, love it. But yeah, so JavaScript object notation is kind of, it's all in the name, right? So this is basically what a JavaScript object might look like in your sketch, except, we're quoting it here to, denote the fields inside our object, which we wouldn't do if we were writing it inside our sketch.js file, for example. So here we have a object, has a weight field, a lifespan field, and a color field. So it's 61.5 weight, don't know what unit that is. Lifespan is 55, don't know what unit that is. And it's brown. So yeah, we know some things about this, whatever this is. But But yeah, there are a few different types are allowed inside JSON objects. So you can have strings, as we can see here. Color is a string. You can also have integers. You can see here lifespan is an integer, and you can also have floats and doubles where weight is one of those. You can also have other stuff, so arrays, objects, booleans, so you can nest these. So for example, color might be like another nested object that is, I don't know, what kind of color is it? It's, it's got a red value, a green value, a blue value, a hex string, who knows? One thing that you can't do with JSON files or, JSON objects that you can do with JavaScript, like inside your sketch file, is have a function inside your object. So you can't write functions inside JSON notation. That is a limitation. But yeah, so that's kind of generally what a JSON object looks like. So how do we get JSON into P5? So just like when we were using a CSV file, JSON has a load JSON function, which we'll have a look at in a moment. So here we've loaded the JSON in. Again, we've taken our variable data, assigned load JSON mammals.json to it, and then if we were to call weight, then we've got 61.5, which, as you remember from here, was the field. So it's a little bit different from the CSV files. So here, instead of being like get column called weight, because the objects have a name for their fields, we can just directly access them as if they were a standard JavaScript object. So we can just say data.weight and get that field straight back out. So that's something nice for working with these JavaScript with JSON. Let's have a look at the reference just to see if there's anything extra here that we can kind of glean. So yep, again, they're doing it in preload here. They're doing it from a website, which is kind of interesting. So load JSON, and they're throwing in a URL instead of a file. So we will have a look at loading stuff from API later on. Let me just check the time. Hopefully, how we're doing for time, 1 hour in. All right, yeah, hopefully we should get to that. But yeah, so they're doing it here. So having a look at the features, which is presumably a field inside the earthquake object, looking at the first thing, and then properties, magnitude. These are all various bits of data that are presumably inside that JSON object. Let's have a look at what the reference says. So we have a path, some JSON-P options. I don't know what JSON-P is. Supported by a polyfill. Who knows? Maybe someone can let me know in the chat, or if you're curious, you can Google it. I don't know what JSON-P is. Data type, string, JSON, or JSON-P. Callback, basically, again, similar to the load table function. If you want to specify a callback that gets run once the file is loaded, then you can specify it here. Error callback, similar. But yeah, sort of similar to the load table, but a little bit less options because the JSON-P kind of spec is a little bit more standardized than CSV is. So a little bit easier to work with, I'd say. So let's have a look at, using a JSON file to create an artwork. So we'll come back over to, let's get our data first. So Charles has selected this artist in the Museum of Modern Art as the section that we're going to grab this data from. Automatic monthly update. So, that's nice. We can see that this data is actually still up to date as of 25 days ago. And we can go ahead and yoink this by downloading it. And we've got a nice little JSON file here, which I've already downloaded ahead of time, as you can see by the one, because I definitely prepared for this. So we'll come back over to our P5 online editor. We'll create we can save this and move on and create a new one. We're going to get rid of the load table because we're not using load table anymore. We're going to be using load JSON, and similarly, we're going to get rid of some of these, some of this code here that we no longer probably need, because we're going to be working with JSON instead. All right, so first things first, let's upload this file. So again, come to our assets folder, upload file. And let me go and grab it out of my downloads. Here it is. All right, nice and done. I'm going to say that it's probably not going to load it. Yeah, it's not going to load it. But that's fine. We can explore it here anyway. So we use the load JSON function that we just had a look at. The path is assets slash, what's it, capital? Yeah, artists dot JSON. And that's pretty much it. We don't have to specify anything extra for that. That should just work, hopefully. There is a little bit of a trick, so let's have a look at what the data looks like. So print, if I could type, print data. What does this data look like? Who knows? Let's have a look. It's an object. Now, that might seem a little strange, potentially. So it's an object, not an array here. So it's an object, and the keys to the object are numbers, just as if they were array indexes. So it's a little bit different. It's not quite what we want. If this is just going to how it's be, if this is how it's going to be, we'd probably just rather it be in an array than it be in an object with indexes based on numbers. So there is something that we can do here to convert this. So we say data, so we're updating our data variable is equal to object dot values data. And what that is going to do is basically it's going to take our, JavaScript object, which has a bunch of these, indexes based on the numbers. It's going to throw those away, and then it's going to convert it instead into an array of what these are assigned to, which are, again, objects. So if we have a look at here, constituent ID, don't know what that is, probably some kind of internal indexing for the Museum of Modern Art. Display name, Robert Arneson. Robert Arneson is an American from 1930 to 1992. Not that he was American from 1930 to 92. It's probably, I presume, his lifespan in general, overall. Nationality, American, male. Yeah, begin date, end date. It's a nice kind of way of saying when they lived and died, presumably. Your end date, the expiry date of the human. Anyway. So yeah, we have some fields based on these artists that we're going to be able to use. So let's get rid of that. No longer need that. So let's have a look now what the object of values data has done. So yeah, nice. So we can see here the fact that we've got angled brackets means that it's an array now, no, not an object anymore. So just making sure my chat is still updating. Yep, okay, cool. So yeah, we can expand this again, and we can still see we have Robert Arneson right here. But instead of being the 0th key, he is the 0th index, which is what we want. So let's have a look at what we can do with this data. So let's just kind of explore this data a little bit. So data, I don't know, random index 20. Let's have a look when they began their life. Similarly, we can have a look when their life ended. We can also see, let's have a look at, I don't know, how many entries there are in the data set. I think that's how you get the length of an array in JavaScript. I don't know. And let's also have a look at the first element in here as well. So we'll comment that out so we don't get confused about what's coming out. So, contestant number 20 was born on 1867 and passed away 1941. So a little while ago. We have 15,250 entries in the array. And again, we see Robert Arneson as our first element. Very cool. All right, let's start drawing some things based on it, shall we? Again, if you have any questions as I'm going through, feel free to just drop them in the Teams channel, in the thread. So, just having a think about what, you could do here. So, I was thinking that might be interesting to play around with the begin date and end date for these artists, because that's, a numeric kind of value. We're not going to have to do any kind of natural language processing or anything like that. So we're not going to have to pass their nationality or name or anything like that. So I think that that's probably what we're going to work with. because they're probably going to be in like quite a large like time span. I don't know if we're going to be able, like, I was thinking about it. I don't know if it's like the easiest thing to use the year directly. So what I think instead I'm going to do is I'm going to draw some lines based on their lifespan of these artists, and see if that turns out to be anything interesting. So let's begin, shall we? First of all, let's have a look at some of the lifespans of these people, just like we did before with the cities. We got, the highest population, the lowest population. We can do something sort of similar here, to have a look at when the first person was kind of born, when the last person, passed away. Similarly, we can also find the longest lifespan as well. So first, well, let's call that min begin. Who began the first? Let's max end. Who ended the last? Presumably that's just going to be 2022. I don't think that's going to be particularly interesting, but we'll see. Maybe no one died as an artist this year. Let's just maybe. Let's also have a look at who had the longest lifespan as well. Let's set these to sensible starting values. And similarly, we're going to use our for of loop to iterate through the array. So const, we can call them an artist of the data. Cool. So let end date equal artist dot, was it end date with a capital E or lowercase e? I wasn't sure. It is a capital E. All right, artist dot end date. Let start date. Oh, call that data, not date. Whoops. Equal artist dot start date. All right, nice. I presume that there are going to be artists who either there's no information on, or they haven't died yet. I'd like to think that there are people who exist who haven't died yet. So we're going to basically say if end date is less than or equal to 0, or begin date is less than or equal to 0, we're just going to assume that those values are not relevant. Potentially they may need some extra handling. We could investigate this further, but for now, for the simple example, we're just gonna throw those bits away. So continue being the keyword to continue with the next loop iteration and skip the rest of this iteration. So that's basically what we're doing here. If their end date or begin date, or sorry, that's meant to be start date, not begin date. If their end date or start date is less than or equal to 0, then we're going to skip this artist. So then we say if min begin, actually we should say if start date is less than min begin, then that gives us a new leader for the earliest artist available in the MoMA dataset. So min begin is equal to start date. And then basically similar thing for the end date. So if end date is greater than max end, then max end is equal to end date. Cool. So this should get us our list of, this should get us the earliest beginning year for the artist, and then this should get us the latest final year for the artist. Now we just need our longest lifespan. So we can also say let lifespan equal end date minus start date. That's presumably how long someone has lived for. So similarly, if lifespan is greater than max, or longest lifespan I called it, then longest lifespan is equal to lifespan. All right, nice. So now let's print out that information. So we'll use our format string. Longest lifespan is longest lifespan. Min is min begin, and max is max end. All right, let's have a look. I don't think we're doing anything else that should cause errors. Let's have a look what's going on. So longest lifespan is 0. All right, I've clearly done something wrong. Let's see, what did I mess up? If lifespan is end date minus start date, that makes sense, right? If lifespan is greater than longest lifespan is equal to lifespan. Why did that not work? Min 1,000,000, max 22. All right, that doesn't. All right, I've clearly made some mistakes here. If start date. I know what mistakes I've made. Spelling mistakes. Okay, so that should be a capital S, and then in theory, life is good. All right, life's not good. All right, what's gone wrong? All right, so start date is equal to artist.start date, and then start date. If start date is less than min begin is a large number, then min begin is equal to start date. Are we not picking up start date somehow? Is that what's going on here? Is anyone seeing anything obvious wrong with what I'm doing? If end date is less than or equal to 0, if start date is less than or equal to 0, continue. Well, we're getting a max end. So that's 2022. That makes sense, right? If end date is greater than max end, then yeah. If start date is less than min begin, did I call it min begin? All right, let's have a look. Does start date give an array? I don't think so. Start date should be a. Oh my god, it's not start date. Oh wait, no, never mind. It's begin date. Yeah. Okay, cool. Love it. Great. Imagine remembering things correctly. Begin date. All right. Let's see how we're going now. Nice. All right. 130. That kind of seems long. I don't know. I can't imagine an artist living 130 years, but maybe they did, I guess. The min year 1181. Not bad, you know, nearly 1,000 years ago. And 2022, as, you know, kind of expected. Unfortunately, some artists did pass away this year. But yeah, let's print out let's have a look at who these artists are with this lifespan. So if we print out the artist dot, is it display name? Yeah, display name, and then also lifespan, so we can see how long these people are living. This is of course going to be iterative, so it's just going to kind of print as we find new maximums, just so we can see who's living a long time. All right. Manuel, presumably. Manuel Bravo, 100. Nice. All right, we got some 100 people. The Union paper bag machine. All right, that's kind of cheating. We don't. All right. It's fine. It's fine. We can consider the Union paper bag machine company a person for now. It's just going to make my life simpler to not have to cut this out. But yeah, okay, so the oldest artist was 108 when they passed away. So that's kind of, you know, that's an achievement. 108, quite a long time to live. Lenny Mathey. Let's have a look at this person, you know. Have a quick squiz. 1873 to 1981. Jesus. All right. Well, congratulations, Lenny. You lived a long time. Looks like you did some interesting art as well. So, very nice. Anyway, back to our sketch. So we have a little bit of data about this. So we know that min year is 1,181, max year is 2022, and longest lifespan is 130. So we can kind of do some things based on that information. So as I mentioned before, I'm going to draw some lines based on how long these people have lived. So let's have a look-see, shall we? I'm just going to borrow this loop again, do the same thing. I'm sure there's smarter ways of doing things, but I'm not going to bother trying to figure that out. And instead, I'm just going to do a new list here. The min. Yeah. Okay. Yeah, we probably could do that. As Melody suggested, you can use the min and max functions with an array. And yeah, that would probably give you more, better data points, less potentially less error prone than writing them out like this. But I just wrote them out because I forgot that min and max could actually take arrays. So we all learn. We all learn. But yeah, that's good. That's a good point, Melody. So thank you for that. So let's have a look. See, shall we? So we are going to say that I'm going to work in black and white here. So let's go. We're on a black background. Don't need the HSB color mode. We do want stroke because we're going to be working with lines. Lines are based on stroke. So we want a white stroke and a stroke weight of like 1 should be fine, I think, because it's going to be like a single pixel wide. I think similarly, so let's see. So basically what I'm imagining is that because there's going to be quite a lot of data entries, there's 15,000 data entries, I'm not going to be able to do like one pass across the whole canvas. We've only got, I don't know, like what, 1,000 pixels here to work with. So we could do that if we wanted to use the whole canvas, but we're only going to get 1,000 data points. So if I want to display a little bit more, what I'm going to do is I'm going to have like rows of lines. We'll see how that turns out. So I'm going to have X here, and we're also going to have Y here as well. So this is just going to be our coordinates. Right, okay. Yes, right. Yeah, the 3 dot notation. I forgot about that. Yeah, so the min and max, you can use, there is this like idea of a 3 dot notation to expand out arrays into a list of single elements, I guess, for passing into functions that are variable length. For example, the print function is just, you can just keep adding commas to it and it will keep adding things to the print statement. But yeah, I'm not going to go into that too much right now. You can have a look, you guys, if you're interested, you can have a look into it later. Potentially, Melody can post a little link to somewhere that explains it. But anyway, I'm going to continue with my artist artwork. Kind of meta. All right. Anyway, let's see where we're up to. All right. So we have our X and our Y here, which is going to be help us draw our lines. Similarly, we want to get the same thing that we had before. So we're going to grab the artist end and start date for each one. Again, that's probably, I'm copy pasting. I'm sure there's a smarter way of doing this, but just for this toy example is what we're going to work with. If either of these are less than or equal to 0, we don't want to draw them. Similarly, I'm going to grab this line of code again. And then we are going to start doing some stuff. So lifespan is equal to end date minus start date. That's going to give us the length of our line. And then we're going to draw our line. So line. This might be a little long, so I'm going to separate it across multiple lines. So our line is going to start at X, and then it's going to be at Y. Actually, let me do the increment for the X and Y first, just so I can visualize it in my head a little bit more. So basically what we're going to use is we're going to have X, and we're going to increase X until it reaches the width of the canvas. And then once X reaches the width of the canvas, we're going to reset X, and we're going to increment Y by how long we want the spacing on the lines to be. And because we already know that the longest living artist is the Union Paper Bag Machine Company for 130, we're going to just make that 130 pixels, nice and easy. So if X is greater than width, then we say X is equal to 0, Y is equal to Y plus longest, longest lifespan was what we called the, was it? I think, yeah, longest lifespan is going to be it. We're just going to use that directly. So, and then otherwise we are going to increase X by some value, probably like, I don't know, 3, 4, give it a little bit of spacing between the lines. And that's pretty much it. So that's how our values are going to increment through our loop. So draw a bunch of lines across one axis, and then once we've reached the end of the width of the canvas, we're going to reset down and increase our Y offset so that we're coming further down the page, and we're going to do the same thing. Yeah, cool. All right, thanks, Melody, for that link. If anyone's interested, feel free to go there. I'm sure it's definitely useful. I mean, maybe I will after this lecture as well. So let's have a look here. So I want all of the lines to be centered along along the middle of the axis, so not drawn down from the top. So because of that, we are going to do a little bit of math here, to kind of figure out where the starting point of our line is going to be. So we're going to say y plus longest lifespan, which is going to be 130 in this instance. We want it to start in the center, right? So if you can imagine 0 is here and 130 is here, we want to be at half that. So y, but of course, because we may not necessarily be drawing on the first one, we need to add y to it, which is why we've got y plus here. So y is initially going to start at 0, and then once we reach one iteration, it's going to become 130, so we're going to move it down. So that's why we're starting with y here. So y plus longest lifespan divided by 2, that's going to get us into the middle of the current row that we're doing. And then what we're going to do is, because of the way a line works, you basically specify the start point and the end point, draws a line between the two things. Very easy. So we don't want to actually start in the center of the line. We want to start at the center of line, but half off. So however long this line is going to be, we want to make sure that the center of that line is in the middle of our row, basically. So this already gives us the center. This is the center of that column, of that row in the vertical axis. And then we're going to take off the lifespan divided by 2. So that's going to, however long that line is, divide that by 2 and then subtract that from the middle. And that's going to get us our start point. And then similarly, we want it to finish on the same x-axis. It's going to be a vertical line. And then basically we're going to copy paste this line and then change that minus to a plus. And then that's going to take that other remaining half of the line and put it below the middle. So that should work out, hopefully. If anyone doesn't understand how this works, feel free to ask a question. I'll try and draw it out a little bit more clearly. But I think that might just work. So let's see how it turns out. All right, nice. All right, cool. Kind of looks a bit like a sound file on like SoundCloud, I think it is, which is kind of harrowing if you think about it, because this is like the lifespan of people as a song. I don't know, kind of interesting. I think it looks kind of interesting. Maybe sorry, maybe you guys think it's a bit boring. But yeah, so we've basically iterated over all of these artists, and we're drawing a line here based on the length of how long they've lived. So you can see some people have unfortunately died rather young. So you have some lines here, for example. This one's quite short. This one's quite short as well. If you wanted to, you could probably order these by instead of just iterating through the artists in the order that the MoMA dataset has been provided in, you could instead order the artists by by their begin date, so that you can see how the lifespan of artists has increased or decreased over time. Maybe artists' living conditions were better 100 years ago than they were now. Who knows? So that might also be a further bit of work that you could do using this to figure out where if there is any kind of trends in it. But here I'm not really looking for trends. I'm just looking to kind of display this data in an interesting way. And I think that this doesn't look too bad. Maybe you guys can disagree with me and come up with a much better artwork and post it in the chat for us. But yeah, so that's basically how you work with JSON here. So because we had our fields, we were able to directly access them without doing, the get 0 or get column name, whatever, that we had to do with the CSV. So yeah, that's how JSON kind of works in P5. Let's have a look where we're at with the lecture. How are we doing on time? 11:30, all right, about half an hour left, all right? Maybe need to speed things up considering we're not very far through it. But yeah, so the difference between tables and objects, I mean, they're kind of similar. A table is a nice way of kind of representing a bunch of similar data. Objects, you can kind of get away with having different versions of data. So If you think about it, maybe like if you had let's say, types of animals or something like that, and certain types of animals might have certain properties that other animals don't have. So if you were thinking about it in a spreadsheet, you would need a column for every single property of every single kind of animal. Whereas when you have JSON, you can kind of leave out, you could leave out the key for, like, let's say a sugar glider isn't, venomous, presumably. So we don't need to have the venomous field in the sugar glider object. But if we were doing it in a table and we had a venomous column, then we're going to have to put something in there for the sugar glider, even though it's not actually venomous. Maybe you can correct me if I'm wrong. If the sugar gliders are actually venomous, who knows? But yeah, so that's kind of, sorry, I jumped the gun a bit, I guess. That's kind of like some useful differences of using JSON versus like using CSV. You can easily omit things that are not relevant instead of just having a bunch of empty, like, cells or commas if you were thinking about a Excel file or a CSV file. There's a question for you. Is one more useful than others for different kinds of tasks? I mean, I guess the answer to that is yes. Sometimes a table makes more sense. If every single bit of data is going to have every single, data point in a column, then maybe a table makes more sense here. And then likewise, when you have that animal example, if you're going to have things that are different bits of data, then having a JSON object might be more of an advantage there. Extra admin corner. I don't think we have extra admin. This potentially is leftover from last year, so I'm going to move along. All right, so just going to take a coffee break. Yeah, sorry. For those of you who don't know me, I don't talk heaps, so this is kind of starting to degrade my throat. So hopefully we last out the rest of the 2 hours. But yeah, so API data. So what is an API? Basically, an API is a application program interface, I think. Yeah. API is, that probably doesn't mean anything to you. An API is like an interesting way of getting data out of, various places or sources online, and it means that we can have some kind of more, momentum or up-to-dateness for our data. So we could have something such that our artwork, I don't know, pulls the weather data every hour and then updates what the artwork looks like once it receives that information. So you can have like an artwork that becomes more, alive, I suppose. It's something that's going to change with regard to the current things, the current state of the world. So when we were doing the artworks just before, we were downloading files, right? Which is like, our JSONs, our CSVs, things like that. Those aren't going to change. Like we created those artworks and they're always going to look the same, right? Unless we change those files, because our artwork is not contacting anywhere. It's not like going anywhere to get anything more about that information. It's just using what is there locally. So they're always going to be the same. But when you're using APIs, things are getting a little bit more interesting. You can start to do kind of, different stuff with that. So hopefully we'll have some time. We can have a look at a small example using an API, and then maybe that's something that you want to do in your major project, just in the lab to test out, have some fun with. But yeah, APIs where we can start to kind of really get a little bit more interesting kind of output from our from the data sources. Have things evolve over time. Yeah, so as I mentioned, using data to drive an artwork is a great way to connect with the real world. If your data is being pulled directly from the internet, you can have it so that your artwork is updating with that data. Yeah, so as I mentioned before, API stands for Application Program Interface. I'm not going to go into it too much, neither do you. You don't need to know too much about this, unless you're a computer science student, in which case maybe you'll learn a little bit more about it later on. But basically, it's just a way or an interface for means for getting data in and out of some kind of program. So, for example, a website might host, I don't know, meteorological data. I'm saying that right? Probably not. I don't know. Pokemon data. There we go. It's something that is easier to understand. My website might host Pokemon data, so that website might have an API for you to get and pull information about certain types of Pokemon. So I could be like, get Pokemon type grass, and then that's going to return me a JSON list of, or a list of JSON objects of all the grass type Pokemon that it has information on, that kind of stuff, right? And yeah, as I mentioned before, the reason that we want to use APIs is because it makes things, automatic, and it means that your artwork is going to update in potentially real time. So that's kind of cool. So yeah, let's dissect what an API URL looks like. So if we go to this link here, we can see that we've just received a bunch of text back. So potentially maybe some of you have already accidentally stumbled across things like this. Maybe you've already accidentally stumbled across an API instead of a website. So, this is a standard link, but instead of providing me a human readable website, we've instead got a machine readable JSON output. And that's kind of what APIs are. It's for machines to talk to machines. So let's have a look. Let's kind of break this down a little bit. So we can see that it looks like a relatively normal website. So data, Brisbane, Queensland Gov. So presumably this is some kind of data provided by the Queensland government about Brisbane. /data/API. All right, we're getting a little bit more of a trail of crumbs here. So we're going into the API section, action data store, yada yada yada. Who cares? But yeah, so that's kind of the base point of our URL, and then we have a parameter here. The resource ID is, I don't know, some kind of ID for something, and then we have another parameter here. The limit is 5, so we want 5 data points. Presumably, is what this is telling the API. So basically, what this is saying is, go here. I want the data that has this ID, and I want 5 data points from here. So if we have a look at this, and I didn't have this prepared, but let's just have a look at like a JSON formatter. Hopefully something not terrible comes up. Let's paste this in here, process. All right, nice. So we can see here that we've got 5 objects, and these objects look like leisure center. So maybe these are pools. Yeah, okay, they're pools. All right, so we have found an API for data about public swimming pools in Brisbane. Very useful for us, I'm sure. So we can see where it is physically, what kind of parking it has, what facilities it has. So this one has aqua aerobics, disabled access and facilities, heated pool, indoor pool, outdoor pool. So yeah, kind of nice. We can call them if we wanted. Probably don't do that. Don't call them unnecessarily. I'm sure they're busy. But yeah, so this is information about public swimming pools in Brisbane. So yeah, whereabouts are we at? So that's kind of an example of an API here. Maybe we can draw an artwork with that. Maybe we won't. I don't particularly know what I would do with public pool information in Brisbane. Maybe you have an idea. Maybe you can use that. But yeah, so APIs, nice little way of kind of getting data out of a website about a certain thing. How do we do that in P5? I'm glad you asked. We have this function called HTTP GET to basically hit a URL and get data out of it. And this is kind of coming back to what I was talking about before, where we have the idea of a callback. So you actually notice here that HTTP GET is not being assigned. It's not being assigned to anything. We're passing in the URL, which is I don't know, some data from the ACT government by the looks of it, and we are saying we're expecting a JSON response. Not sure what. Maybe we'll have a look at the reference in a moment. But here, this argument, we have a callback function, and basically what's going to happen is that this callback function is going to be called once the data has been loaded, and the response from the web request is going to be the argument to that function. So here we've just got a nice little anonymous function, which is basically saying make our data variable equal to the response from the website. Yeah, that's pretty much what the weirdness is. So let's have a look at the reference for HTTP GET. How are we doing for time? 11:38, not too bad. All right, so here we're having a look at the URL. Here it's for earthquakes in the US, presumably it looks like. And again, they have this response callback to assign the response to the earthquakes variable that they created. And that's pretty much what we kind of expect, right? So path, name of the file or URL to load, data type, basically what we're expecting to get back from the website. Generally speaking, we're expecting to get JSON back. Sometimes you might get other files or other types of data. Generally speaking, we're going to get JSON. But you know, if you find an API that's giving you something different, then we have different options here. Data object boolean parameter data pass send with request optional. I don't know what that is. Probably something else, I guess. Callback, as I mentioned, the function that's going to get called once the data is loaded, and then error callback, something to be called if you can't actually get the data. Cool. So let's where can we get data? So pretty commonplace for finding APIs about data is government websites or specific institutions that have their business to do with data. So the BOM, for example, Bureau of Meteorology, I think it's called, they would have an API presumably for people to get information about weather and whatnot. Similarly, you know, governments are probably going to have information about census, public transport, pools, like we saw, public pools in Brisbane, things like that. So there's a whole range of places that you can kind of get data from. And if you want to use that in your major project or anywhere else like that, then I recommend that you do so. I think visualizing data is a pretty interesting thing to do. So yeah, lots of different places that you can kind of find APIs and get data. All right, let's do a little toy example using public transport data in Canberra. So let's make an artwork on how many people are using Canberra's public transport. Here's some data on how many passengers travel on different services each day. Let's have a look. Yeah, so that was the key that we used before. So it was updated on September 25th. Let's have a look. Can we download it directly from here? Oh, data. All right. Well, so this is kind of what our data is probably going to look like. So has the day, and then how many people took each kind of each kind of public transport. So on the 30th of the 6th, there was 8,122 people took the light rail and actually paid. Presumably they're not doing image recognition to recognize people who haven't paid, I would assume. 1,309 people took the school route, 68 took other. I don't know what other is, but I guess they have some kind of other public transport that they're also measuring, although it seems to be rather small. But yeah, so we have some information about the data that we're going to get here, so we can make an artwork based on that. Here's the JSON version. All right, nice. Yeah, cool. So this is they've been nice to us and formatted it in a more human readable way. Usually you're not going to get like when you're looking at the raw JSON, it might just be, you know, one big line. So here they've actually put new lines in it for us. So we can see here that there's some information and again, just the stuff that we saw before. Who's taken what. Here we can see that these are wrapped in strings, so these are going to be strings presumably when you load them into the JSON data. But we can do some processing to make them not be strings. Here is an example of just one day, so you can have a look here in the URL that we've passed in a specific date into the. Oh, you can't see the URL. Very sorry about that. What would be the best way to fix that? I'm not 100% sure. You're just gonna have to trust me on it. I'll just post the URL into the Teams chat. Actually, maybe that's the best thing for it. So yeah, you can see here in the URL that you have like a little clarification here in your parameters. So the date is the 5th of the 10th in 2020, and then that's given us a single day's worth of data. So just like we were looking before with the limit and things like that, different APIs will have different possible parameters to get different data sections. Anyway, so let's have a look at Charles's artwork about the light rail. So let's just have a little dissect here before we go ahead and run it. So we can see here that we have our data. We're getting the data from that same ACT URL for the public transport. We have our HTTP GET call here using the URL as the argument. We're expecting JSON as the return type. And we have our callback function here, which basically is assigning the response to the data variable. Because this is a web request and separate with the callback function, it's not something that is going to be completed before the preload function finishes, unfortunately. So what you can do is basically check to see if data is a thing inside your draw loop. So here we have an if statement, which basically says, if not data, then we are returning. Basically, we're finishing this draw loop. We're not going to continue any further. So this code, all this code here from line 19 onwards is not going to run unless there is something in data. So if there's something in data, then we're going to change the fill, stroke, get the data, get the row for that specific day. So this is something that's presumably going to be iterating over days per draw loop. And then we're plotting the light rail, the amount of people who took the light rail journey as the size of our ellipse in this artwork, and then we're incrementing the row. So basically, we're going through each day that's available in the data set. So let's have a look at what that actually ends up looking like. Yep, presumably pretty wild. So I presume what we're seeing here is that majority of people are taking public transport in the weekday, and then on the weekend we have those two little inner circles that are a little bit lighter, less people taking the public transport on the weekdays because people aren't going into work, whatever. And then this is kind of the representation of it. And then I guess like over time, different months, maybe different people are taking public transport. Maybe more people take it in the summer and things like that, and maybe less people are taking it in winter or the colder days, things like that. Who knows? That's just my guess, but it might be something else. Potentially this data is spanning COVID as well, so potentially the section around COVID is going to obviously have a lot less people out and about and taking public transport. But yeah, so this is an example of how you would use an API to get something that's changing over time. And then basically anytime you refresh this artwork, if this value, like if the data at this endpoint has changed, then your artwork is going to change, which I think is pretty cool. So let's move on. So let's have to wind the lecture up, let's have a look at some examples of data art that already exist. So here's an example by Ben Schneiderman and some others, I guess, in 1990. It's basically a visualization of, I'm not actually 100% sure. I thought I had a look at this, but I'm not quite sure. But it seems to be some kind of visualization of potentially a program or something else, some kind of system, and it's drawn out in a nice little kind of graphical way. But would you consider this an artwork? It's hard to say. I don't know if I would necessarily consider this an artwork. It's data that has been presented in an interesting way. Whether or not this classifies as an artwork is another way. So there's kind of two usual examples that you find of database display. So one example would be presenting data in an aesthetically pleasing way. You'll find that a lot on like Reddit, for example. So like the data is beautiful subreddit will have a lot of examples of data that's presented aesthetically, but it may not necessarily be an artwork. And then the other example is obviously data that is presented as something that is meant to be an actual artwork. So an example of data that is actually being presented as an actual artwork is this one here from Anna Madeline Ropak. Hopefully I said that right, probably didn't. It's called Controlled Burn. The medium being burnt matches and pencil on paper. So this artwork is basically the artist has taken matches and burnt them to represent presumably some aspect of climate or climate change in the ACT. as kind of a stark reminder of how this is affecting us more obviously being bushfires. If anyone was here in the 2019 season, they'll remember how bad the bushfires really affected Australia. So yeah, this is being, it's a very visceral kind of representation of that. Very one kind of analogous, where we have the burning of the matches being, the burning of the trees, or bushfires. Very kind of literal there. And then she has burnt the matches to represent some value. So how much the match is burnt is obviously corresponding to some data point. So quite interesting. And yeah, it's been presented on paper and then put in a gallery. So this kind of, I would say that this checks out more as like an actual artwork than just an aesthetic display of data. But yeah, this is kind of this is very physical, obviously. It's not something that's going to change, not something that's going to be able to be hooked up to an API or anything like that. So we can have a look at some more digital examples. So this is a bit of an older one, I think. It's called the Packet Garden by Julian Oliver. The idea is that this is a program that you install and run on your computer at home. Sorry. It's a program that you install and run on your computer at home, and it will transform and meld itself based on your internet activity. So, for example, when you make a connection to some website or some server, it creates a little tree or a little flower to represent that connection. And then when you do a download, it becomes a valley. And when you do an upload, it becomes a hill. So you can see here that we have some downloads here, some connections around here, and then some uploads here. So it's really quite an interesting idea of how you might go about representing, potentially mundane data as something that as an artwork, and this one here being a computer-based artwork. Here's another one: Shoots and Ladders, Sandy Rides by Natalie Maybach. So this one here is actually about, it's commentary on the Hurricane Sandy, I think it was, disaster that happened in the US, and kind of how that impacted them. So basically, the idea is to be able to represent the kind of like nature of what climate change is affecting us through sculpture, and kind of draw some parallels. So like, the event being like the hurricane, but then also the event being like, theme parks and things like that. And it's kind of drawing lines between these two things. So that's quite interesting. Again, another physical one. This is not a digital one. So let's have a look at another digital one. This one's particularly relevant for you guys because this was actually made in P5, this one here. So this one here is by Sharon Brand. She's from New Zealand, I believe. It's a interactive generative artwork based on data from COVID-19. So I think it's to represent caseload and spread of COVID-19. As I mentioned, there are a lot of artworks that are based on kind of climate change and COVID-19 when it comes to looking at artworks that involve data. Those are just kind of, the two main events that we can kind of represent using data nowadays. Of course, you can represent a lot of other things, but these are just like, good talking points or good public talking points. COVID-19 is starting to wind down a little bit now, but of course, this was very relevant a year, 2 years ago. So basically, the way that this artwork works is it takes a image of the user using the website, using your camera, and then uses that as an input to then create a generative artwork, and then also kind of links that into the COVID-19 data and starts to kind of become, a generative artwork piece. So really quite interesting, really relevant to you guys. So if you want to have a look at it, I highly recommend that you do. And maybe it can give you some ideas about how you can have more interesting input into your sketches. So this one here being using a webcam as an input, and that would be definitely something that you could do for your major project if that's what you would like. But yeah, I think that kind of covers it. So there's some extra areas that you can have a look at. Again, as I mentioned, the Data is Beautiful subreddit, not necessarily always going to be artworks, but still aesthetic representations of data. I can give you some ideas. And then a few other ones here as well that you can have a look at. So data art and flowing data, digital age of data art, 6 artists who've submitted digital art, and a TED Talk. Always nice. I'm not going to go and have a look through them now. If you guys are interested, you can have a look in your own time. And I think that pretty much wraps us up, and kind of nicely as well. Only a couple minutes left on the lecture. So does anyone have any questions about anything that was covered today, or just questions about the course in general for the last kind of 2 minutes? But yeah, I'll wait a little bit in the Teams chat. Hopefully you guys enjoyed the lecture. It was my first time doing one for this course, so hopefully it wasn't too bad. But yeah, thank you all for everyone who tuned in live. Really appreciate that, and anyone who contributed in the chat as well. But yeah, I put on a little bit of closing music as well for us. Oop, not too loud. That's perfectly fine, Melody. It's always good to have more information about things. I mean, you know, I'm here to learn with you guys as well, not just some body of knowledge. And all right, cool. If there's any further questions, feel free to post them onto the discourse, or you can drop them in the Teams, and potentially might wait around another couple minutes and answer them then. But other than that, thank you all for tuning into the lecture, and I hope you have a nice rest of your day.